Extracting meaningful insights from big data is no small task. The nature of big data plays a critical role in determining the infrastructure and technology tools required to manage and analyze the data and derive its value. Apart from being classified as structured and unstructured, big data is also categorized as data at rest and data in motion. Each of these categories has different infrastructure requirements. Let us understand these categories in some detail. Data at rest refers to the data that is captured at asynchronous intervals. This data can be stored in a hard disk and flash storage and can be retrieved and analyzed after the data creating event occurs. Let us understand this better with the example of a retail store. A retailer uses the analysis of the previous month sales data to decide the marketing strategy and business activities for the present month. Using this data, the retailer can decide on the kind of marketing strategies that will entice its customers and increase sales. While the data provides value, the business impact is limited and dependent on the customer coming back to the store to take advantage of the marketing activities. So, what are the infrastructure requirements for managing and analyzing data at rest? This data is usually managed by batch processing or online transaction processing methods and therefore does not need an on-demand infrastructure. However, the infrastructure must be scalable and support large data sets for both transactions, that is RDBMS, and analysis, which means data warehousing and business intelligence. That was about data at rest. Let us now discuss data in motion. Data in motion is the term used for data as it is in transit over a network. Often, businesses need to manage and process large volumes of data that is continuously flowing into the business. Such data captured at frequent intervals, typically from electronic sensors and devices, is called data in motion. But then, how is data in motion different from data at rest? The key difference between the two data sets is at the point of analytics. Unlike data at rest, data in motion analytics occurs in real time as the event happens, and organizations stand to gain tremendous opportunity to improve business results in real time from the insights gained from streaming data. For example, theme park operators can collect data streaming in from the wristband sensors that are provided to customers during their visit to gather data on customer movement, choice of rides, and other activities, and use this data to personalize the customer's visit with recommended activities and offers in real time. So, what are the infrastructure requirements for handling and managing data in motion? The volume and velocity of such data type will be very high, and you need various tools to process such continuous streams of data. We have just learned what data in motion is. Let us now discuss a few more examples of how organizations are using data in motion. At the end of this video, you should be able to explain the use of real-time data in various industries. Explain the elements of real-time analytics. Let's look at the use of data in motion or real-time data in healthcare and managing vehicular traffic control. Picture the scenario of a hospital ICU. Electronic devices continuously monitor various medical parameters of a patient. However, there are multiple patients with various medical conditions in the ICU. Considering the criticality of the patient's conditions, doctors need to be alerted if there is a breach in the threshold value of any parameter at any given point in time. In this scenario, there are vast amounts of data in the form of parameter values flowing continuously into a computer system. Such data is real-time data. For alerts to be raised, such real-time data needs to be processed and analyzed to check for any breach within very small time windows, within the computer memory, and while it is flowing. This is done by various big data technologies. Let's look at another scenario of real-time or streaming analytics in another industry. Traffic intersections in most cities now have video cameras to monitor the traffic situation. Thousands of such cameras stream traffic images at any given point in time across a city. To spot a traffic violation in real time and penalize the offender requires you to process data in real time and take action in sub-second response times. Having seen some examples of real-time or streaming analytics, let's understand the elements in real-time analytics. Elements in real-time analytics include sensors, monitoring of parameters in real time, ability to detect normal and abnormal events in real time, event processing algorithms or event handling rules, reporting and visualization, and threshold values. First are sensors. Sensors help detect various parameters in real-time data. For instance, thermometers help measure the temperature of a patient. The next element to consider in streaming analytics is the monitoring of parameters in real time. Additionally, the computer system needs to be able to detect normal and abnormal events in real time based on the stream of data flowing into the system. Streaming analytics also needs to consider complex event processing algorithms or event handling rules. For instance, to find a drug to cure cancer, you would need to analyze approximately 2,000 parameters across a huge number of patients. Complex event processing algorithms help in such cases. Another element of streaming analytics is manual or automated detection and alert mechanisms, such as in mobile alarms. Reporting and visualization is another element that needs to be considered in streaming analytics. The footprint of the output device is shrinking. Technology can now be used to display data that earlier used to be displayed in big screens, such as the ones in stadiums, in smaller screens, such as your mobile phone screen. Another element to be considered in streaming analytics is the threshold values. You need to adjust the threshold values using machine learning techniques. For instance, if through history 100 airplanes have crashed due to various reasons, big data algorithms need to be programmed to have records of each of these crashes and measure those parameters in real time to alert airplanes with similar situations. Such a process of setting up a machine with algorithms to perform in a predictable manner is called machine learning. Now that we have discussed the various elements in streaming analytics, let's see if you can answer this question based on what you've learned so far. If you selected intercepting traffic data from video cameras at traffic intersections to provide the best route to an ambulance, you are right. Data in a disk and hourly temperature updates displayed in a mobile phone app are data at rest, since they are not continuous streams of data. Let's do a quick recap of what you've learned in this session. Data at rest is captured at asynchronous intervals. Data captured at frequent intervals, typically from electronic sensors and devices, is called data in motion. The volume and velocity of data in motion is very high, and you need various tools to process such continuous streams of real-time data. Real-time analytics is used in various industries. Real-time analytics considers various elements such as implementing sensors, monitoring parameters in real time, detecting normal and abnormal events, implementing complex event processing algorithms, implementing manual and automatic detect and alert mechanisms, reporting and visualization, adjusting the process model threshold values using machine learning techniques.